So exercise 1104 is about radians. So we learned a little bit about radians from chapter 5. I'm just going to quickly review what we learned then. So we learned that 2 pi radians, the exercise 1104 is about radians. Now we did learn about radians in chapter 5. We learned that there are 2 pi radians in a circle. And I'm just going to review a couple of results from that. So 2 pi is equivalent to 360 degrees. Pi then is equivalent to 180 if you halve each of those. If I divide each of these by pi, this is 1 radian is equivalent to 180 over pi. So that's a useful conversion that we can use. If I go back to here and divide each side by 180, I get that 1 degree is equal to pi on 180 radians. So we can use those for conversions. So here's an example. The first question says convert 3 pi over 2 to degrees. Now you notice I'm not putting any symbol here for radians. It's just automatically known that it's radians from the context. I have seen situations where there's a little C for radians, or they'll write the word rad, but it's not required. It is a unit of measure relative to the radius of the circle, but it doesn't need a symbol there for it. Now, there are 2 methods to do this one. So method 1 is we can quite simply just replace the pi with the 180 degrees. So 3 times 180 over 2. So 180 over 2, of course, is 90, so 3 times 90, so 270 degrees. I often also think about the fact that 3 on 2 is like 1.5. So it's like, so 1 pi is half a circle, and then another half brings you around to the 270 degrees. And we'll look at that again on the next page as well. Now, method 2 is where we use our conversion. So we know that 3 pi on 2 is in radians, but we also know that 1 radian is equal to 180 on pi in degrees. So we can actually multiply that by 180 on pi. An easy way to remember, a lot of time people get these back to front, which one to multiply by. One easy way to remember it is the pi's at the top here, the pi's at the bottom here, and they're going to cancel out, and that's what we want. Once they cancel out, then we've just got this exact same calculation we had here, 3 times 180 over 2, which is 270 degrees, the same answer. Okay, in number 2, we're converting 75 degrees into radians. So for this one thing you can do is like work out what fraction 75 is out of 180. Because you're kind of working out if 180 is 1 whole, 75 degrees, well, it's less than half that. It is in the first quadrant somewhere. It's a bit less than half pi. I'd like to just use this method 2 process. We need a pi in the numerator, so we use this to multiply by, and we get 75 times pi on 180. And just simplifying that down, you can just put the 75 on 180 in your calculator. It's 5 pi over 12. Okay, this last one, convert the square root of pi over 4 to degrees. Now with this one, you cannot use this method. If you replace that pi with 180, you're actually going to get the incorrect answer. This method does not work. You must use this method for this one. You can try that. Try putting the square root of 180 into your calculator. Try replacing the pi with 180 and see that you do get a different answer. So for this one, we do need to convert by multiplying by 180 on pi. Now, if we wanted that in exact form, the 180 over 4 is 45. We could simplify down the root pi and the pi to have just a root pi on the bottom. So that would be an answer in exact form. But that's also equal to 25.3885, etc. degrees. And if I go into degrees and minutes, that's 25 degrees, 23 minutes, and 19 seconds to the nearest second. So I've just added this little note here about not replacing the pi with the 180. So each of the results that we've looked at with the unit circle can also be looked at in terms of radians. So this again is 0. We know all the way round is 2 pi radians. We know that halfway round is pi radians. So halfway from 0 to pi is pi on 2 radians. And down here, that's 1 and another half. So that's 3 pi on 2 at the bottom. So we can look at all our results for the different quadrants. We've still got all stations to central. So I've drawn these triangles into each quadrant. So where this triangle in the first quadrant, where that's theta, we can find, sine, cos, tan of theta using our x and our y coordinates of this point. So if we go into the second quadrant, when we do it in degrees, we said that that was 180 minus theta. This is theta here, which means that's also theta. That's the related angle. So this angle to this point, instead of 180 minus theta, it's pi minus theta when we're working in radians. This related angle here is theta, so all the way from 0 round to this line is going to be pi plus theta. Okay, pi plus theta to get to there, to that line, all the way anti-clockwise from 0. And then this one, if this is theta in here, this is 2 pi minus theta. But the cool thing is that each of these triangles is identical, so finding sine, cos, and tan of each of those is the same. So we can find all these results that we had before. So if we're in the second quadrant and we're going anti-clockwise, we're up here, we know that sine is positive and the other two is negative. So we can straight away say that sine of pi minus theta in the second quadrant is equal to sine of theta, both positive. Cos would be negative, so that's equal to negative cos theta. So really all you're looking at here is the positive and the negative factors. So tan is also going to be negative tan theta. Now pause the video and see if you can work out quadrant 3 and quadrant 4. So I'm going to keep going with it. So in quadrant 3, it's T, tan is positive. So tan will be the one that's exactly equal. And then for sine and cos, they'll be negative. So negative there and negative there. In quadrant 4, all stations to central, C, cos is the positive one. So cos of 2 pi minus theta is equal to cos theta. Sine and tan will both be negative, but still the same answer. So we're relating them back using that related angle back to the first quadrant because the triangles are identical triangles. Now if I was to go clockwise, if I was to be looking at negative numbers, then going from here down, that angle would be negative theta. So in quadrant 4, if I have sine of negative theta, then I'm coming back this way round. So I'm going to get cos positive, but sine will be equal to negative sine theta. Now these three results here, tan of course negative, they relate to odd and even functions as well if you think back. It tells us that cos is an even function and that sine and tan are odd functions. So remember your f of negative x equals f of x, like cos, that's even. And for an odd function, f of negative x equals the negative f of x. And sine and tan are both odd functions. Now if we're in quadrant 3, we're coming all the way back over here. So it's the negative of this one up here, the negative of that one. So for example, if I was in degrees, that might be something like negative 135 degrees, not quite 180. So 135 is 180 minus 45. This might be pi minus pi on 4, which is the same thing. But, so these are in quadrant 3. It's much easier to work out when you've got actual numbers. So because we're in quadrant 3, tan is the one that's positive. Cos and sine will both be negative. So really this is just about working out positive or negative. So in quadrant 2, sine is positive, and quadrant 1, they're all positive. So quadrant 2, this is the positive one, these are negative. And then back in quadrant 1, they are all going to be positive. Tan theta. So let's look at some examples where it is numbers. Now, when we're finding exact values, we're always using these triangles. Now, normally this one's 45 and that one's 45. So 45 degrees, that's a quarter of 180. Okay, so if I said, what's 45 out of 180? Oh, let's turn that on. What's 45 out of 180? You can see that is a quarter, so that's pi on 4. So 45 degrees is pi on 4, and so that one up there is pi on 4 as well. Now remember, this is normally 60 and this is normally 30, and on your reference sheet it only has them in degrees, so you actually have to work out the radians. So if you say what fraction is 30 of 180, that's 1/6, so that's pi on 6. So this 30 degree one is pi on 6. And what ratio is 60 out of 180? That's a third of 180, so it's a third of pi. So that's pi on 3. Now, here's a really, really, really easy way to remember that. Pi on 3 is opposite the one that's 30 degrees, so they've both got 3's in them. Pi on 6 is opposite the one that's 60 degrees, and they've both got 6's in them. So it's like the 3 and the 6 are switched from the 30 and the 60. And that technically works up here as well. This is 45 degrees, so that one's over 4. This is 45 degrees, so that one's over 4. Now, that's just coincidence for those two triangles, but it's a really useful little rule that you can use to remember those. So sine pi on 3 is this triangle, it's this angle, it's √3 over 2. It's an acute angle, so it is just positive. Now, cos of 5 pi on 4, that's not an acute angle, so we do need to use our all stations to central and work out which quadrant we're in. So 5 pi over 4, that's a little bit over 4 pi on 4, isn't it? So 4 pi on 4 is just pi. So it's going to be in this quadrant. We know that's pi, and we know this is 3 pi on 2. And the key is working out here that 5 on 4 is a little bit more than 1, but it's not quite 1.5. Okay, so we're in this quadrant. So all stations to central, tan is positive, so this is going to be negative. Oops, equals negative. And then we just need to find the related angle, this one in here. Now, so this is 5 pi on 4. So if we subtract those, now to do that in your calculator, it's great if you know your fraction calculations, because that's 5 on 4 minus 4 on 4, which is easy, it's 1 on 4. It's going to be pi on 4. But if you're not so good at that, what you can do in your calculator is just do 5 on 4 minus 1. So just don't put the pi's in, just put the coefficient. This is 1 pi, so 5 on 4 minus 1, and it tells you it's 1 on 4. So that angle is pi on 4. So this is going to be equal to the negative cos pi on 4. So this is just your related angle in here. And to work that out, back up here at this triangle, cos of pi on 4 is 1 on √2, adjacent on hypotenuse. 1 on √2. Now you could also be asked about sec and cosec. I have not actually included those in my examples, but obviously if it was cosec pi on 3, you'd just flip that upside down. I might just write that here as well. So cosec pi on 3 is 1 over sine pi on 3, which just means to flip that, so that's 2 on √3. Sometimes they might want you to rationalize that as well. Okay, let's look at this last one, tan of 13 pi on 6. So what I'll often do is I'll actually say, well, where is 13 pi on 6 around here? Now, think about over 6. if we break that down a little bit, multiples of 6, so that's the same as tan of 12 pi on 6 plus pi on 6. Right, so I need a multiple of 6 here so that this simplifies. And this is just 2 pi. So this is 2 pi plus pi on 6. So you're going all the way round to 2 pi plus another pi on 6. So the answer will actually be exactly the same as tan pi on 6 because we're back in the first quadrant. And it's going to be positive, of course, in the first quadrant because they all are. Pi on 6 is up here. So opposite over adjacent, 1 on root 3 is the answer. So I've just written some steps there. So step 1 is to use your all stations to central, work out if it's positive or negative. Step 2 is to find that related angle. So that's the angle to the x-axis. Okay, to x-axis, to the closest x-axis. And then use the exact value triangles.